This is Core Mathematics C12 Sample Assessment Material Part 1 Questions 1, 2, 3, 4, 5. This is question number 1 and it is indices. 1a deals with x to the power a to the power b, then we can write x to the power a times b. That means the indices are multiplied. 25 x to the power 4 whole to the power 1 by 2. The first thing that we have to do is to make sure we express the entire thing as one exponent or index. 25 can be 5 squared, x to the power 4 to the power half. So we can write 5x squared whole squared because the power can be taken common. And we already have a power over the power which is half, and we can multiply that. So this 2 and this 2 cancels off and the answer is 5x squared. Question number B. So we have the same thing, but the power this time is 3 by 2. So we have 25 x to the power 4 to the power 3 by 2. We can write it as 5x squared whole squared, just like last time. So we don't have to show the steps here. Multiplied by 3 by 2. This time this 2 and this 2 cancels off. So we have 5x squared whole cubed. That means 5 to the power 3 x squared to the power 3. 5 cubed is 125 and x squared whole squared, the exponents are going to be multiplied, x to the power 6. Apart from the main rule, one rule we have used over here is the concept of if you have x to the power n times y to the power n, we can write it as x times y whole to the power n, and that's the concept used here. So we have 5 squared x to the power 4, so we can take the square common and we can write 5x squared whole squared. Question number 2, binomial series. What we have to do is we have to expand this binomial series up to the first 3 terms in ascending powers of x. So the first thing that we write is 3 minus x to the power 6, and we have to make this 1 because in the syllabus what we have to do is the format of 1 plus b to the power n, where n is an integer, and it would be 1 plus nc1 b to the power 1 nc2 b to the power square. So the same thing has to be done here, but the first step is to make this 1. Let's take 3 common. It would be 1 minus x by 3, and we have the whole thing to the power 6. The next step would be 3 to the power 6, 1 minus x by 3 to the power 6. Now 3 to the power 6 is 3 to the power 6, 729. So 729, and this is going to be 1 plus nc1, which is 6c1, b is minus x by 3, remember the negative sign also, plus 6c2 minus x by 3 squared. Now let's simplify this. 1 plus 6c1 is 6 multiplied by minus x by 3. That means plus 6 minus x by 3 plus 6c2. Let's calculate this. 6. Now for c we have to press the shift button. c2, and that is 15. So this is going to be 15 minus x whole squared is x squared, 3 whole squared is 9. Now let's simplify. 729 into 1 is 729. 6 divided by 3 is 2, and we have a minus. 729 times minus 2, that is minus 1458. Minus 1458, and remember the x. Then we have 15 by 9 times 729. So that would be 729 times 15 by 9, and that is 1215. So plus 1215 x squared. and we have to give this plus dot dot 2 to give the idea that the series continues. Now remember, these are the first three terms. It is not up to x cubed. It is the first three terms, that means up to x squared. This question says, answer this question without the use of a calculator and show all your working. What this means is we have to make sure the calculation work is shown. Even if you use a calculator for checking, that is fine, but make sure you show the steps. Now this is a third question, part of the indices. A third is a special index where we have the power as half. So question number 1, we have to show that the left hand side 5 minus square root of 8, 1 plus square root of 2 when multiplied together has a plus b square root of 2. The answer has to be an integer. So let's multiply this. So what we have to do is we have to multiply 5 with 1 and then 5 with square root of 2. So 5 ones are 5 plus 5 into square root of 2 is 5 square root of 2. Then we have to multiply square root minus square root of 8 into 1 and minus square root of 8 into square root of 2. So that turns out to be minus square root of 8 into 1 is minus square root of 8, and minus square root of 8 is, remember, minus square root of 8 times square root of 2 is square root of 16, because we have this rule, square root of x times square root of y equals to square root of x times y. Now let's simplify that. So we have 5 minus, now square root of 16 is 4. So 5 minus 4 is 1. Then we have 5 square root of 2 times square root of 8 is basically 2 square into 2. That means 8. We can write 1 plus 5 square root of 2 minus, if we bring the 2 square outside, it would be 2 square root of 2. So 1 plus, now if we take square root of 2 common, it becomes 5 minus 2, which is 3 square root of 2. So when they said without using the calculator, they meant you have to show square root of 8 is 2 root 2. Otherwise, if we press the calculator, you will directly get the answer 2 square root of 2. That is the main step. Now question number 2. Now show that square root of 80 plus 30 divided by square root of 5 is the same as c square root of 5. Now for this sum we have to rationalize. Now one way of rationalizing is to multiply the downstairs square root with upstairs. For example, if you have a square root of b, to rationalize we have to multiply square root of b both upstairs and downstairs. That way the square root would disappear from downstairs. So square root of 80 needs to be simplified, but there is nothing downstairs. But in the other term, 30 by square root of 5, let's multiply square root 5 upstairs and square root 5 downstairs. So let's simplify. Now square root of 80 can be written as, we know 9 5s is 45 and 45 2s. Let's break it down over here. That is the best. Let's break down 80. So we have 2 4 0, 2 2 0, 2 10 and 2 5. So let's see how many squares do we have. We have 2 square, we have 2 square, we have 5. So we can write 2 square times 2 square times 5. And here we have 30 into square root of 5 is 30 square root 5, and square root of 5 and square root of 5 multiplies to just 5, because remember, when we have square root of x times square root of x, it is only x. So now let's simplify. If we bring the 2 square outside the square root, it becomes 2, and then if we bring the other 2 square outside, it would be another 2. So we will have square root of 5 plus, now this 5 and this 30 cancels off as 6. So this is 6 square root of 5. So we have 4 square root of 5 plus 6 square root of 5. Therefore 4 plus 6, it is 10 square root of 5. Now one thought about writing down the answers. It is important to see how do they want you to write down the answer. So here they said, show that this is equals to c square root of 5, where c is an integer. We have shown it is 10 square root of 5, and therefore c is an integer because 10 is an integer. That is fine. In question number 1, they said show this is equals to this, giving the values of integers a and b. So we have given the value of a as 1 and b as 3, but since they said giving the values, it's a good idea to write down as a equals to 1, b equals to 3. Question number 4, calculus. 4a is differential calculus, where we have to differentiate a Cartesian equation and find dy by dx. So the question is y equals to 2x to the power 5 plus 7 plus x to the power minus 3. It's a good idea to write down such that all the powers of x are upstairs, be it positive or negative. So what we have to do over here is differentiate y. So this would be dy by dx. Then we have to differentiate 2x to the power 5. It would be 2 is the constant, and x to the power 5 would be 5 x to the power 4. Plus, if we differentiate 7, it would be 0. Plus, if we differentiate x to the power minus 3, we would have minus 3 in front, and then the power would reduce by 1. Remember, if it reduces by 1, it becomes minus 4. So let's simplify this. This would be 10x to the power 4 minus 3x to the power minus 4. Now I want to mention one thing. One of the line that we don't have to write is the differentiation of both the sides. So what we have is d by dx of y on this side, and d by dx of the entire expression 2x to the power 5 plus 7 plus x to the power minus 3 on the other side. So this is one line, because when we differentiate an expression, we write d by dx and then give the brackets. But when we have to differentiate a Cartesian equation, remember, we have to differentiate both sides. Question number B is integration, and it is indefinite integral. That means we have to write a plus c at the end. So integration of, we have 2x to the power 5 plus 7 plus x to the power minus 3 dx. So 2 is the constant. If you integrate x to the power 5, it would be x to the power 6 divided by 6, plus if you integrate 7, it would be 7x, plus if you integrate x to the power minus 3, the power would increase by 1. That means it would be minus 2. Minus 2 is greater than minus 3. Think of the numbers as a ladder. So divided by minus 2, and we have a plus c. So this would be 2 divided by 6 is 1 by 3 x to the power 6 plus 7x. Now this is minus, since it is 1 by minus 2, it would be minus half x to the power minus 2 plus c. Remember, differentiation and integration, they are like opposites. The fundamental rule of integration says that, of calculus, the fundamental rule of calculus says that integration is the opposite of differentiation. That means if you differentiate an expression like d by dx x squared, you'll get twice x. Now if you take this twice x and integrate it, you will get 2x squared by 2, and then there is a plus c. Now why do we have to give plus c? The reason we give plus c is because if you had to differentiate x squared plus 1, the derivative would be twice x. If you differentiate x squared plus 2, the derivative would still be twice x. So what happens? We are never going to get the constant, because when you differentiate a constant, it becomes 0. For that reason, when we want to get back the original expression, we know there could be some constant. That's why we write plus c. Question number 5 deals with trapezium rule. Now what trapezium rule does is find an approximation of an definite integral. It is an approximation for a definite integral. But since definite integral, this integration, for example 2 to 3, and we integrate it, since integration gives us a finite area of finite region, so we can say trapezium rule helps us to find an approximate area. So let me write down the trapezium rule. So the trapezium rule goes like this. area equals to h by 2 y naught plus twice into y1 plus y2 and on, and finally the last value of yn. So this is the trapezium rule. What is h? H is x1 minus x0, the difference between x. So where do we get the x and the y? You see the table that is given over here, that table, this is the first value x0, this is x1, this is x2, this is x3, this is x4. So from here we can calculate h equals to x1 minus x0, 2.25 minus 2 is going to be 0.25, and it can also be found by subtracting the next one like common difference. The next thing are the values of y. So the values of y are, this is y0, this is y1, this is y2, this is y3, and finally this is y4. So the formula is, let's write it down, area equals to h by 2, h is 0.25, divided by 2, y0 is 0.5 plus 2 into y1 is 0.379 plus y2 is 0.299 plus y3 is 0.242 plus 0.2 bracket closed. And now we have to calculate this. Now when you calculate this, remember, to avoid errors, the best thing to do is to start with the innermost bracket. So the innermost bracket is 0.379 plus 0.299 plus 0.242 equals to is 0.92. Now multiply by 2, 1.84. Now let's add the first one, 0.5. So this would be plus 0.5. Then let's add the last one, 0.2, plus 0.2. Now outside we have 0.25 by 2. So let's multiply by 0.25 and finally divide by 2. What we get is the area, 0.3175. 0.3175.